Picking up where we left off on the last video, we can convert a sulfonic acid into a phenol by something called alkali fusion. And this is something that is actually not done that often because it requires pretty extreme temperatures. So you add sodium hydroxide and heat, and that heat is 300 degrees C. And so that causes all kinds of reactions that you don't really want to happen if you have other functional groups on there. And then after you do that, then you add H3O and you convert that into a hydroxy group. So it turns out that this reaction right here you can't do if groups other than our groups are present. So you can have, methyl, ethyl, alkyl groups hanging off you here and do that, but you can't do it if you've added an amino group or a nitro group or something else on there, because those groups under these conditions will end up getting destroyed, converted into something else, or knocked off completely or whatever. But this is one way that you can convert benzene into a phenol by putting a sulfonic acid on and then converting it to the hydroxy group. And again, you can pay attention to the directing abilities here. We have a meta director to start with, and then we end up having an ortho-para director. And so if you pay attention in your synthesis, if you need something that's meta to this group in the final product, then make sure you direct it there before you do the conversion. But the only thing you can direct there would be an alkyl group. If you direct anything else there, it'll get destroyed in this conversion. Or again, if you want something ortho or para to it, then you can then you wait until after you do the conversion, which would be generally safer unless you have an alkyl group there. Okay, so then the next one, we can convert a sulfonic acid into benzene. We can replace this sulfonic acid with a hydrogen by adding H3O. So think about that for a second. How do you get benzene sulfonic acid? Well, you start out with benzene and you add sulfur trioxide and sulfuric acid to put it on there, and then if you wanted benzene in the end, then wait. We started out with benzene, so why are we going to convert it to this sulfonic acid and then take it off again? Can you remember any other time in this course? I can't remember now if we did something with blocking groups of the first semester or not. But this is essentially a blocking group, which means if there is a position that you don't want to add something else to, say you're adding a bromine and you don't want it to add in a particular position, then you can direct the sulfonic acid there first, and that will block that particular position while you do something else, and then you can take it back off again. And so you will see once we start doing synthesis how valuable this can be. But this conversion here back to taking off this group completely is part of the blocking process, where we want to protect a certain position on the ring and keep it from reacting just temporarily, and then taking it back off again. Okay, so if we have in the last one here, if we have an alkyl group that is attached, we may want to add a bromine onto there. And why do we care about having halogens in particular positions? Well, they are really good leaving groups. And so it provides a position of reactivity here. If we put a halogen here, then we can do an SN2 reaction on it, or an elimination reaction and form a double bond here as well, but it produces a point of reactivity, and there's lots of things that we can do. We can build off of here if we want to have a branch there or whatever. So this is a good leaving group, and to get that on there, we add NBS, N-bromosuccinimide, and you are familiar with that from allylic bromination from last semester. But what it does is it replaces one of the hydrogens in the alpha position next to the benzene ring. And this position, this is called benzylic bromination. Because this carbon right here is the benzylic carbon, or the benzylic position. So when you hear about the benzylic position, that is the position on a chain, the one that's right next to a benzene ring. And that should ring a bell, because you have, when we learned about naming aromatic compounds, we learned that this was a benzyl group. You know, I misspelled this. It's B-E-N-Z-Y-L, I think, benzylic, because this is a benzyl group. Okay? But, you know, lots of interesting molecules don't just have pharmaceutically interesting molecules, biologically interesting molecules, just don't have alkyl groups. They have other groups hanging off, and this is a way of making it reactive in that position. But the point here is that you need to have a hydrogen on that carbon in order for it to react. And so if you had an isopropyl group there, you have a hydrogen, and you add NBS, and you can do this reaction. Oops, I've turned it a little bit sideways here. You can put the bromine here. If you have a T-butyl group, however, you do not have a benzylic. In the benzylic position on that carbon, there is no hydrogen to replace. And this NBS, what it does is to replace the, running off the bottom here, it replaces a hydrogen here, and if there is no hydrogen there, then you get no reaction. So this is a nice set of reactions to convert one functional group into another, and this greatly increases your ability to build compounds starting from benzene, when you can convert them to other functional groups. And some of these functional groups you can convert further. If you have an amine here, you can convert that into, you can add alkyl groups on there, so you can convert that to form a secondary amine, a tertiary amine, or an amide. All those things this can be converted into. So another variety of things that you could convert it to. And then carboxylic acids also can be converted into other functional groups, and other carboxylic acid derivatives, such as amides or esters or anhydrides or things like that. So this is giving you an entry point into other a variety of other functional groups. So, moving on from here, your next videos we're going to start thinking backwards. We're going to start doing synthesis, looking at our target molecule that has benzene and 2 other things attached or 3 other things attached, and figuring out what we have to add first to direct the next group into the right position so that both of those groups together will direct the third group into the right position.